Hello everyone and welcome to my YouTube channel, Fellow Engineers. In this video I will be reviewing straight lines, which will be categorized under the mathematics portion of my YouTube videos. If you guys enjoy the video, please make sure to like and subscribe. And if you guys have any suggestions on how to improve future videos, I'd really appreciate it if you guys left comments down below as well. So without further ado, let's get right into it. So shown here is one of the four quadrants shown on the x and y axis. So we're showing the positive and x and y axis. And before we get into important equations and example problems, let's start with just understanding the schematic as well as terminology. So the blue line is one random line that we selected, and it has a particular axis, which is shown as the slope of the line, which is going to be the variable m. As you see in this schematic for this line, it crosses the positive y-axis, so that is going to be labeled, that point on the y-axis, the y-intercept, and that's going to be the variable b. So that will have the coordinates of 0, b, because the 0 meaning that is the coordinate location for the x point, and b being the point where it crosses the y-axis for this line in particular. Aside from the y-intercept being the variable b for when a line crosses the y-axis, we also have an x-intercept, which is when a point on this line that crosses the x-axis. For this schematic in particular, it's going to be crossing the positive x-axis, so we have a variable for the x-intercept being the value of a. So the coordinates that will cross the x-axis will be a, 0, so any value, 0. Okay, so now moving away from the x and y intercepts, there are infinite amount of numbers or coordinates possible on a slope. Shown here is just one of many possible coordinates, which is going to be x1, y1. Okay, so now getting into our first equation. Shown here is the equation that we can use to calculate the slope of a line if we are provided with 2 points on that particular line, given the points x1, y1, along with another point x2, y2. And we can find the slope, which is the variable m, by using y2 minus y1 as the numerator of a fraction divided by x2 and x1. And it's important to keep in mind that it does not matter which ones you assign x2, y2, and x1, y1 to which coordinate, but it does matter you are consistent with the location of these values in the equation. So let's work on an example problem. So let's find the slope of the line that passes through points -6, 3, and 3, -3. Please pause the video here to attempt to solve the problem on your own before proceeding to the solution. Okay, so with us being given two coordinates in the problem statement, with those being -6, 3 and 3, -3, we are given all of the unknown values that are used to determine the value of the slope of this particular line. So we're going to use the slope of the line equation as shown here. So for this example, I assigned coordinate 1 to be -6, 3 and coordinate number 2 to be 3, -3. Now it doesn't matter, like I said in the previous slides, that which one you assign which, as long as you remain consistent. So from the coordinate 1, -6, 3, I assigned x1 to be -6 and y1 to be 3. And for coordinate 2, x2 to be 3 and y2 to be -3. Now with us assigning values to each of the x and y points on both coordinates, we are able to simply just plug in these values into the equation for the slope of a line shown here. So after we utilize our calculator that we have on hand, or can do some simple mental math, we calculate the slope to be -6/9. But we can go a little step further and simplify that out a little more, making that -2/3 for our slope. If two lines are perpendicular to each other, then their slopes m1 and m2 are the negative reciprocals of each other. For example, if we have a slope of 3 for one line, and the slope perpendicular to that line would be -1/3. For example 2, a line goes through point 6, -5, and is perpendicular to the line y equals 3x plus 8. What is the equation of the line? Please pause the video here to attempt to solve this problem on your own before pursuing further through this video for the solution. So to start this problem off, we will assign the slope of line 1 to be the value of 3, which is given to us in that slope equation of y equals 3x plus 8. With m1 being the slope 1 being a value of 3, we know the slope perpendicular to that is -1/3, which is the negative reciprocal of the slope. So with us knowing the slopes of the line perpendicular to the provided line, we will now try to find the y-intercept, which is the variable b, to determine the equation of a line for the given coordinates and slope. So by utilizing the equation of a line as shown previously, we are going to use this equation to find the variable b, which is the y-intercept. So the values that we will be utilizing are the coordinates 6, -5 for the x and y value, as well as the perpendicular slope we just determined to be -1/3 for the m value. This allows us to calculate a y-intercept, or variable b, to be a value of -3. Okay, so now that we were able to determine what the slope is for line 2, which is -1/3, along with the y-intercept being -3, we are now able to use those values to substitute into the equation of a line and come up with the equation y equals -1/3x minus 3. And this is the line perpendicular to the other line y equals 3x plus 8, as well as the line that goes through the coordinate 6, -5. Now let's get further into several important equations for lines. For starters, we have the standard form equation of a line, which is y equals mx plus b. The m variable stands for the slope of the line, the b is the y-intercept, and the x and y variables are considered a coordinate along the point of line. We also have the general form of the equation of a line, and is represented as ax plus by plus c equals 0. And it could also be rearranged in order to determine what the standard form of the line of the equation is. And lastly, the point slope form equation of a line, which is y minus y1 is equal to the slope times x minus x1. This equation defines the line in terms of its slope m and is known in a known point given the coordinates x1 and y1. For example number 3, let's find the slope of a line defined by y minus x equals 3. Pause the video here to attempt to solve the problem on your own before pursuing to the next portion of the video for the solution. By utilizing the standard form equation of a line, also known as the slope-intercept form, we can rearrange the given equation to find the slope of the line. As you see in the given equation, we have y minus x equals 3 for the standard form equation. The y is by itself on the left side, so to achieve that the line equation we were given, we simply have to move x over to the right hand side of the equation by simple addition. By doing that, we get y equals x plus 3. Now with the slope of the line being the variable m in the standard form equation y equals mx plus b, you may notice that there are no numbers alongside the variable x. That doesn't mean the slope is 0, it actually has a number of 1 in front, but it doesn't have to be shown since the value is a value of 1. So that means that we found our slope to be a value of 1 for this problem. For equation 4, what is the general form of the equation for a line whose x-intercept is 3 and its y-intercept is negative 2? Pause the video here to attempt to solve the problem on your own. For starters, let's write out the formula we are trying to achieve, which is in this case the general form equation ax plus by plus c equals 0. The first step in solving this problem is to determine what the slope is. It may not be obvious at first, but in the example problem we were given two coordinates of the line, the first coordinate specifying the point location when it crosses the x-intercept, and the second being when it crosses the y-intercept. When it crosses the x-intercept, the value of y will be a value of 0, giving us the coordinates 3, 0. And when it passes the y-intercept, the x value will be 0, allowing us to determine what that point is as well, being 0, negative 2. With us now obtaining two coordinates, we can use the slope of the line equation to determine what the slope is. By plugging in the values in the correct locations, we are able to calculate the slope of the line to be 2 over 3. Now that we know the slope, we can plug in the values to get the line to be in the general form equation. General form is, like I previously stated, just a rearranged version of the slope-intercept form equation. As you see here, I rearranged the standard form equation to be in terms of x, y, and then a constant, as shown the slope times x minus y plus the y-intercept, which is equal to 0. We will then plug in all the variables, replacing the slope, which is the variable m, with the calculated slope we just determined to be 2 over 3. And also we will replace the y-intercept, which is the variable b, with the given value of negative 2. So that could be considered the answer, but let's take it one step further and simplify this equation out a little more. So we have a fraction 2 over 3 shown with the variable x, so we can actually multiply 3 out, to each of the other variables to get all the fractions eliminated and get all the integers present. So when we multiply 3 out into each variable, we get 2x minus 3y, and then a minus 6, which is equal to 0. And this is the final answer for us to determine what the general form of the equation of a line is, with the x-intercept being 3 and y-intercept being negative 2. For example 5, a circle with a radius of 3 is centered at the origin. What is the standard form of the equation of a line tangent to this circle at point 2, 3? Please pause the video here to attempt to solve it on your own. For starters, we know the slope of the line from the origin to the point, which is 2, 3. You can use the slope equation of the line with 2, 3 and 0, 0 being your two coordinates. Now that we have the slope of the line from the origin to the given point, we now want to try and determine the slope perpendicular to that slope, which is also the slope of the line tangent to the circle. As we know, the perpendicular slope can be determined by taking the negative reciprocal of the original slope. So with the slope being 2 over 3, the slope perpendicular to that will be negative 3 over 2. Now that we have the slope tangent, also known as perpendicular to the circle, we want to determine the equation of the line. And by doing that, we are going to use the point slope form equation because we are given a point along the line being 2, 3, and the slope now determined to be -3/2. As you see here, we have plugged in the values in the appropriate locations with y1 being 3 and x2 being 2. We also place the perpendicular slope in as m. To simplify the equation, we multiply the right-hand side out. The last step in order to determine the equation is to get in standard form is to rearrange the equation to get y all by itself on the left-hand side. By doing this, we will simply add 3 on both sides. By doing that, we have calculated the equation of the line in slope-intercept form, tangent to the line at the point 2, 3 to be y equals -3/2 x plus 6. The last equation we will be reviewing for this lesson will be calculating the angle between two lines. The figure represents the two lines with any slope. The Greek symbol alpha represents the angle we are looking to determine from this equation. The equation utilized to determine this angle is alpha equals the tangent inverse, or arctan, multiplied by the slope of line 2 minus slope of line 1, and that will be divided by 1 plus the slope of line 2 times the slope of line 1. For example 6, we are looking to determine the angle between the lines y equals 3x plus 5 and y equals 4x plus 3. The first step is to identify the slope of each line. For this instance, we are assigning m1 to be the slope of the line y equals 3x plus 5, which has a slope of 3, and for m2, we'll have y equals 4x plus 3, which has a slope of 4. Now that we have the two slopes, we will be able to utilize the equation previously introduced for an angle between the two lines. With us assigning the values to both slopes, we simply need to plug in the values. Once simplifying the equations, we get an angle to be equal to arctan, or tan inverse, of 1/13. And when entering these values into your calculator, you'll end up getting an angle of 4.39 degrees. So that includes my video reviewing straight lines and a variety of important example problems, as well as important equations utilized to understand straight lines more. I hope this helped you in any form of way, and have a great day.